Hello students, welcome to my channel. So I have completed 3 chapters in chemistry and today we'll start with the 4th chapter, which is carbon and its compounds. So let us just recollect from the time you wake up in the morning till the time you go to sleep. You perform so many activities during the day. So just remember and recollect all these activities, and for all these activities that you do throughout the day, you use some products in your life. So just let's note it down. You wake up in the morning, then you brush your teeth. So you use a toothpaste to brush your teeth. So toothpaste, then you have your breakfast and you go to school. So you either have your breakfast or you carry a tiffin box, and which is food, right? You carry food or you have your breakfast, meals. Then you go to your school through some means of transport. Either you use a bus, you use a two-wheeler or a four-wheeler, any means of transport. So for that you require fuel, right, for the vehicle to move. And the fuel is either made up of diesel or petrol. So it's either you're using diesel or petrol. So it's a fuel. After you reach the school, then just observe in your classroom around. There are benches that you're seated on, desk, table, chair, doors, windows. Everything is made up of wood. So this is made up of wood. Everything, doors, chairs, table, desk. And also you use notebooks. So notebooks are made up of paper and cardboard. Notebooks. So all these observations that you have made, that things and products that you use have something in common. So which is nothing but carbon. So all these substances, these products, materials, what you use are made up of carbon. They are all carbon compounds. So you can see the importance, how important carbon is in our daily life. We have never realized this, that we use so many things, but they are made up of carbon. And chemistry is nothing but correlating our day-to-day life, our day-to-day observations that we make around us with the theory that we study. So it's nothing but our practical life. So when we correlate and understand this, then learning chemistry becomes very easy. So all these substances are made out of carbon. Carbon is a very important element in our life. So the Earth's crust is made up of 0.02% of carbon. So the Earth's crust in the form of minerals. They are carbonates, hydrogen carbonates, coal, petroleum. So coal, petroleum. I already gave you all the example, which is in the form of petrol that you use for your transport. And in the atmosphere, it consists of 0.03% of carbon in the form of carbon dioxide. So the percentage of carbon in the Earth's crust and also in the atmosphere is so less. You can just see the percentage, but yet its importance and its application in so many uses that we have. So students, you all must have made some observations around you, and let me name few of them. When food is burnt, you will observe that it gets a color, a blackish color or a dark brown color. For example, rice, chapati or roti, it gets a blackish color on it. Also many other food items, you will observe when it gets burnt that it develops a black color on it. So the reason is because it contains carbon. So just remember this, make these observations. Also, another example is clothes. When clothes are being ironed and suppose it gets burnt, you will observe that it gets a blackish color on it. So the reason is because it consists of carbon. So that's the observation. Wood, when wood is used as a fuel, when it's burnt, there is smoke liberated, there is ash that is formed, blackish in color. These are all examples that it contains carbon. Now let us study the bonding in carbon and let us understand what is covalent bonding. So now I will state a very simple example for you all to remember. So when you all remember this example, then you all will definitely remember the concept of covalent bonding. So it's a very simple example, but just for you all to remember. So consider a boy named Rahul. So Rahul is a college going student and he studies in a place away from his hometown. So he needs an accommodation, he needs a place to stay. So he thinks of taking a place on rent. So the place on rent would cost him around 8,000 rupees. He thinks of staying in a flat. So the cost is around 8,000 rupees. So he likes a place, but the cost seems to be too much. So what he thinks, he goes and approaches his friend who is another friend who is David, and he tells him that I loved this place and I want to stay in it. So you think of joining me and we'll share this place. So David also sees the place and he liked it. So both agree and they live in the same place and they share the rent. So each pays around 4,000 rupees. So in this bargain, both are happy, both are satisfied because they got a good place to stay. So this is nothing but sharing. They are sharing the place, and this is nothing but covalent bonding. Both develop a bonding among themselves. Their friendship becomes much better. They develop a bonding which is nothing but covalent bonding. So covalent bonding is nothing but sharing. Just remember that for the benefit of both of them, they have to share, and the outcome is also good. So covalent bonding is sharing. Just remember this. So children, in chemistry, atoms, elements, compounds, all of them behave with the same principle. So when one requires something, another also requires. So they all come together and they form a bonding and they share together, which is nothing but covalent bonding. It's just a name given to it, but it's nothing but sharing. So now let us understand this with the help of examples. So in our previous chapter, we have studied the properties of ionic compounds, also their bonding, and if you haven't checked that class of mine, then I'll be providing it in the iCards over here, so you can just check my class. So by this observation, you can clearly understand that carbon compounds have very low melting and boiling point. Also, they are bad conductors of electricity, which means that the bonding between the molecules is not very strong. Since they are bad conductors of electricity, so the bonding in carbon compounds don't give ions. Children, in your previous classes, you'll have studied about elements, how they react with each other, how they interact with one another to form a compound. So when they combine together, the combining capacity to form a compound would depend on its valency. Now what is this valency? Valency in the sense valence electrons. Now I have explained this in detail in my previous classes. I'll provide the link to that in the description box below, so you can check it out. So as of now, I'll just explain to you all in brief. Consider element A. So element A is deficient of 2 electrons. Deficient in the sense it has less 2 electrons in its outermost shell. And element B has excess of 2 electrons in its outermost shell. So that is the valency. So cation, anion, it's their valency. So one is the cation and the other is anion. So both of these combine together and they form a compound. So that's how ionic compounds are formed by the reaction. So one is having excess of electrons, so one shares, and the other is deficient of electrons, so one receives. So one receives and the other shares. So that's how this is called the combining capacity of elements, that would depend on its valence electrons. Now valence electrons are either they are deficient or they have excess of electrons in the outermost shell. Students, elements have a tendency to attain noble gas configuration. Now what does this mean? Which means that it has a tendency to attain completely filled outermost shell. The outermost shell should be completely filled with electron. Now let us understand this with an example. So consider hydrogen atom. This is the nucleus. Hydrogen atom, the atomic number of hydrogen is 1. So this is the first shell, K shell. So atomic number is 1, that is 1 electron will be here. And the capacity of K shell, the maximum capacity that it can accommodate is 2. So K shell can accommodate 2 electrons. So when 2 electrons are accommodated, it is stable. So that is the tendency of elements to attain completely filled outermost shell. So when the outermost shell is completely filled, it will not react. That is what is noble gases. They don't react at normal conditions. So when it is deficient or having excess of electrons, that's where that atom gets restless. It has the tendency to react with its neighboring atoms. So when it has excess or deficit of electrons, it's very restless, so it has the tendency to react. So hydrogen has 1 electron in its outermost shell And so to attain noble gas configuration, that is completely filled outermost shell, for it to be stable, for it to be a noble gas, like a noble gas, not to react at normal conditions. So K shell has a maximum capacity that it can accommodate 2 electrons, whereas hydrogen atomic number is 1, so it has only 1 electron, so that's where it has the tendency to react. So I'll compare this with the similar noble gas, which is helium. So helium atomic number is 2, so let's see the atomic structure. So this is the K shell. Okay, K shell can accommodate maximum of 2 electrons, and with helium there are 2 electrons, so that's where it is stable, non-reactive at normal conditions. So that is the comparison. So what happens? Hydrogen element has the tendency to attain completely filled outermost shell, which is that of a noble gas. So elements have the tendency to attain completely filled outermost shell with electrons, which is noble gas configuration. Let us understand this with 2 more similar examples. Oxygen has the atomic number 8. So let's draw the atomic structure. So K shell, it gets full, which is 2 maximum capacity. L shell has 6 electrons. So oxygen atom requires 2 more electrons that need to be filled in the outermost shell. The outermost shell here is L shell, and after it is filled, then it will attain stability, noble gas configuration. So let us understand this with comparison with a noble gas, which is neon. So neon atomic structure would be like this. So you can just understand the comparison between the two. Neon atomic number is 10. So the K shell has 2 electrons, L shell has 8 electrons. So you can just draw the comparison between the two. Oxygen, it's deficit of 2 electrons in the outermost shell. That's where it needs to gain stability. It has a tendency to become like noble gas configuration. Neon has completely filled outermost shell. So the maximum capacity that the outermost shell, that is L shell, can take is 8 electrons, and that is fulfilled. So just understand the comparison. Elements have a tendency to attain noble gas configuration. They have the tendency to attain completely filled outermost shell, completely filled electrons in the outermost shell. So oxygen here is deficit, it's lacking 2 electrons, and neon gas, it has completely filled electrons outermost shell. So another example I'll give you all, third example. Chlorine, another element, atomic number is 17. So let's draw the structure. So chlorine atomic number is 17. So K, L, M shell, let's have a look. K shell has completely filled 2 L, 8 and M shell has 7. So let us have a look at the noble gas in comparison. So this is chlorine. I'll show you all about argon. So argon on the other end has completely filled outermost shell. So the outermost shell is M shell, which has 8 electrons. Maximum M shell can accommodate is 8 electrons. So you can just have the comparison between the two. So chlorine is deficient of 1 electron in the outermost shell, and so it has the tendency to attain noble gas configuration and become like argon. So according to the electronic configuration, this is where the shells have their maximum capacity, and with comparison, that is this noble gas argon has completely filled outermost shell, which is not there in chlorine. So that's how the reaction happens with elements. Let us understand this now with respect to carbon. Carbon, its atomic number is 6. So let me just draw the atomic structure. So since the atomic number is 6 and in the outermost shell it would require 4 more electrons to fill its outermost shell completely. So for carbon to attain that of noble gas configuration, it would either take in some more electrons, 4 more electrons receive, or it should give out 4 electrons. So this is a nucleus where there are protons in this and neutrons. For carbon atom to attain noble gas configuration, that is completely filled outermost shell, where L shell will require 8 electrons to be completely filled, carbon atom has only 4 electrons. So it should either receive 4 more electrons or it should give away 4 electrons. Now if it receives 4 electrons, then carbon atom would receive a charge . It would develop a charge which is anion, and when it receives 4 more electrons, the proton number is 6. Remember, we have studied this earlier previous classes, that the number of protons and electrons in an atom are equal. They have same number of electrons and protons. So since the number of protons are 6, and when to attain stability in the outermost shell, it will receive 4 more electrons. So for this proton to hold on to such a big number, such a great number of 10 electrons, it would be very difficult. It would be very difficult to have that energy, that capacity to hold on to 10 electrons, 4 extra. Another alternative is if it loses 4 electrons, so it would attain a charge, and which is cation. So if it loses from its outermost shell, then again proton, which is 6 in number, to hold on to just 2 electrons, these 2 which will remain, it's not possible. So both the alternatives fail. So even if it receives or it gains electrons, it's not feasible for the proton 6 in number to have either of the alternatives. So what happens in this case, this carbon atom, it shares its electrons of the outermost shell with other atoms of carbon. So that's how the bonding develops. They share the electrons of the outermost shell. Remember, it's only the outermost shell, and that's how the bonding forms. This is nothing but covalent bonding. They share, and it doesn't happen only with carbon, but other elements also, other atoms of other elements also have the covalent bonding. So carbon atom shares electrons with another carbon atom, and not only with carbon atom but atoms of other elements. That's how compounds are formed. So let us state some examples and understand some simple compounds where covalent bonding is formed. So hydrogen atomic number is 1. So to fill its outermost shell completely, it requires one more electron. So what they do, one atom of hydrogen, another atom of hydrogen, they combine together and they form a molecule. So they share, that's where what is called as covalent bonding. So this is one atom of hydrogen. So it shares one electron with another atom of hydrogen. So both hydrogen atom combine together and both share one electron each. So they form a bonding, covalent bond, which is in this case a single bond. So this is a single bond. Each of the hydrogen atom, they require one electron to complete the outermost shell. So they combine together, both the hydrogen atoms, and they share their electrons, and that's how they form a bonding. Chlorine, another example where atomic number of chlorine is 17. And it requires one electron to complete its outermost shell to be completely full. And so the same thing happens with chlorine. So chlorine together, they combine and they form chlorine molecule. So single bonding, covalent bond, and the representation would be Cl molecule. With hydrogen, it is hydrogen molecule. So chlorine also behaves in the same manner. Two examples already stated of single bonding. So now let us understand how oxygen behaves. Oxygen atomic number is 8. So it requires 2 more electrons in its outermost shell for it to gain noble gas configuration. So what oxygen does, it shares its electrons with another atom of oxygen and forms a bonding. Oxygen so there are 6 electrons in its outermost shell. So these are the electrons represented. So this is oxygen atom. It shares with another atom of oxygen. So one atom of oxygen, 6 electrons in the outermost shell, which is represented here, 1, 2, 3, 4, 5, 6, combines with another atom of oxygen, 1, 2, 3, 4, 5, 6, and they combine together, they share the electrons and then they form a bonding between the two, which is a double bond. So previous example in hydrogen chlorine, we represented it by a single bond, but here it is a double bond. So this is how the molecule of oxygen is formed. Now let us understand how water is formed. So water is nothing but H2O, two atoms of hydrogen combine with one atom of oxygen. So the valency of hydrogen is 1 and the valency of oxygen is 2. That's how they both combine. So let me represent this with an electron dot structure. So 6 electrons oxygen in the outermost shell represented here. This is oxygen atom. So it combines with another atom of hydrogen. So oxygen has 6 electrons and also hydrogen is in need of electron. Both combine together and they form a water molecule. They form a covalent bond, which is nothing but H2O. Nitrogen has the atomic number 7. This is the atomic structure. So it would require 3 more electrons to fill its outermost shell. So nitrogen atom, it combines with another nitrogen atom. So let us check the representation. One atom of nitrogen combines with another atom of nitrogen and they form a triple bond. So the bonding between the 3 electrons, triple bond, and it forms nitrogen molecule. So let us understand the structure of ammonia. So nitrogen has 5 electrons. This is the structure of ammonia and the electron dot structure would be 5 electrons in its outermost shell, the atom of nitrogen. So it combines with hydrogen, and another hydrogen. So nitrogen shares 3 electrons with hydrogen atoms, and that's how the molecule of ammonia is formed. So the similar thing happens with the carbon compound. The most simple carbon compound is methane. So methane has its several uses. It's the major component of biogas and also CNG, compressed natural gas. So methane is the most simple compound of carbon, and the same thing happens. They share their electrons. This is the structure of methane. The atoms combine together and they form the covalent bonding, which is a single bond here. That's how many compounds are formed. So this is the carbon atom. and it requires 4 electrons, so it combines with hydrogen. So this is how methane is formed. So I have repeated several times so that it becomes a practice for you all and also like a revision. So in my next class, that's part 2, we'll discuss on the versatile nature of carbon. So if you all have any doubts or queries regarding this chapter, this topic that I have discussed, then do drop your comments in the comment section and I'll try to reply to you all at the earliest. So dear students, do subscribe to my channel for regular updates of classes, and I'll see you all in my next video.